Good afternoon. Hopefully you guys had good lunch, and we won't make it. We won't do a lull, so you don't go into sleep. So make it more exciting. So my name is Subra Kumar Swamy. I lead the security architecture and engineering team in Visa. And just to kind of give you a little bit more context of what we do, so we take care of everything that in every single product under Visa. To make sure they are almost vulnerability free. Right? Our goal is to make sure 100% we can be resilient against breaches. But we ensure from live end to end, from architecture design, SSDLC, pen test, post-production monitoring, the whole product security umbrella is in this team. So unlike most companies where architecture is just blueprint, we are actually much more hands-on. So today we are here with the two more speakers. My colleagues here, Vinod and Oleg, they'll be the key speakers. I'm just going to give you the highlights and then I'll hand over to Vinod. So I want to talk about the journey that we had for the last 3 years, right? This has been a very long journey. And before I go into the presentation, how many of you here actually are doing data protection in some ways, right? Which means encryption, hashing, devaluation. Okay, most of you. So in this age, right, as we know that the data is a new currency, and of course hackers want to go after the honeypot where there's value. So the data is going to be, that's the place eventually they want to land in. So our goal, the mission that we established 3 years back, is to ensure that we devalue every single byte that we collect, process, and store in Visa. Right? We have over 3 billion credit cards, and we have over 7 trillion records that we actually try to protect every day. So this is a very monumental task. So we had a very, I would say, the support that we got from the board of directors all the way was unimaginable, right? We got all the support we got. We didn't have any issue with resources. So we were, in some way, we are very fortunate to have very high support, top down and bottom up. So today's agenda, as I said, we'll talk about the why, because as InfoSec folks, right, it's always that we should start with the why before we go and start, giving out the standards and the policies and the solutions. So it's kind of obvious to a lot of people, but it's also a difficult part, right? Because you're trying to explain why is it important for you to think about data security from the get-go. So that's the part I'll be covering. And we'll have Vinod talk about the maturity models. Basically, every company has their own journey, and there are different ways they approach. So we actually looked at one of the things that we assess on a yearly basis. We have Gartner who come and assess our maturity model, right? So take it what it's worth, right? So they have been giving us assessment that we use, and we use that to support the investment decisions as well as be able to plan for the next year. And the building blocks, obviously there are a lot of building blocks that come together to deliver a solution at scale. We'll talk about the benefits and then a quick takeaway. Okay, so now jumping right in. So I want to start with, obviously I don't know how to preach the choir here, right? This is the outdated data here. We're not even showing some of the recent breaches that happened in 2018. So it's a matter of when versus if, right? It's a matter of when the breach is going to happen. And the reason why I want to bring the slide up is, there's a lot of investment that go into information security program, and at different levels. But you have to understand where the attacks are coming from. So this data that we got, I think the source is OWASP. 62% of the attacks are actually exploiting the features. So this is, as you know, features, the developers are measured by the feature velocity and how fast they can deliver the features, right? Obviously, they've been incentivized to deliver things faster and cheaper and innovative way. So when they release a new feature, are the things that can be exploited, right? Those are things that we had to worry about in SSDLC. And 30% of them involve web applications, right? So if you take Equifax, the hackers went right into the struts vulnerability and be able to exfiltrate data. So the web attack surface is growing every year. Obviously, everybody has presence on the internet. And a lot of times, the web applications are talking back to your core services internally through APIs, right? It's no longer a standalone portal. They're all interconnected mesh of web. In fact, in 2005, Amazon went with making sure that Amazon's CEO, Jeff Bezos, sent a memo said, if you don't get on board in a SOAP or in a REST API bandwagon, you'll be fired, right? So that was a mandate that he established to make sure everything is a service. So there is a lot more interconnectivity of services. And the last one is very interesting because no longer the attacks are happening simply through human beings. You can't afford to just sit there and hack. The attacks at the start, the reconnaissance of a kill chain starts at the very early stage with the bots scanning automatically and figuring out where potential weak spots are, right? Once they figure out the weak spots, then you have a human being, now including some of the artificial intelligence techniques are used to go much more deeper, right? So it's kind of a methodical and very sophisticated way of how hackers look at. So it's no longer just users sitting behind a screen. And obviously, data breach comes down to, it's not about, simple brand impact. Obviously, this brand will be impacted. Stock price may take a hit, but it's really an existential threat, right? If you don't do data protection in some ways and making sure you protect your ground jewels, right, it does have impact on the company itself. So with that mandate, right, and kind of pivoting into how companies approach. So if you walk into an RSA conference, right, that happens every year, and by and large, most of the vendors are actually focusing on, appliances, solutions, network security, how do you harden your data center, right? So, but that's 90% of the investments. And, but the attacks, if you look at the attacks, only 25% of attacks are coming through network. Right? The biggest attack most companies worry about on network is DDoS, right? Because that has a high impact on your service availability. But the sophisticated attacks are much more laser focused. They are going to come through a web vector or API vector or some other vectors. So this kind of shows that, the mindset we are still living is that to secure the perimeter. Right, what we call the soft, chewy center secured by a hard shell of M&M security, right? If you flip that chart, 70% of the attacks are coming through web, and yet 10% of the investment are going into the, securing your applications and data. And so I think, sorry, I missed a slide. Okay, sorry, I went too fast. So now coming back to the why. So for us, we worry about obviously the consumer impact. We worry about the regulatory requirements. And now with especially GDPR, right? There is impact on, it's an impact on your bottom line. The GDPR penalties can actually go up to 2 to 4% of your revenue. So if you're making a $20 billion revenue like us, right, that's a significant impact. So we worry about the the cost of remediation. I think Equifax is still reeling from the breach they had, and they're still investing money to work with regulators. Apart from cleaning up, apart from making sure your application is patched. Now we are to deal with all the other post breach, right? Working with regulators, making sure that you have a program that is much more stronger and be able to prove to the auditors that you have raised the bar. The customer loss, right? Obviously, this is something that we always say the consumers vote with their wallet. They have a choice, right? If they have to choose between us and our competition, if they don't trust us, our brand, they will go and reach out to the wallet and get the next credit card or use a different digital payment method. So this is an area that eventually drives us to think about how to ensure the crown jewels are protected. So with that, I'm going to hand over to Vinod, and Vinod is going to talk about the maturity model.
Thank you, Subra. Yes, it's 1 p.m. I know, actually. So I was in a couple of sessions and at 1 p.m., so I know how it will be. So, but I know actually, like Subra warned by giving the numbers, which we always see actually in the newspapers. Okay, and we always reading actually what is happening. Not only we as IT professionals, even high school kids and middle school kids nowadays knows what is happening actually in the data world, the breaches. Okay, so everyone knows actually what is happening, but at the same time, are we really addressing actually that problem, being a responsible IT professionals? So my first job actually in 1998, I developed a crypto component which can be used by ASP applications. It's in 1998. It's like almost like 2 decades I completed. Still, I'm solving the same problem actually, which I started actually 20 years before. It's not because actually the solution is not there. The solution is there for last two decades, but it's not formalized. It's not dictated. It's not pushed by the management. As Subra mentioned, most of them focusing actually on network security, which is far back actually in this infrastructure. But the front ending is web application. Yes, in the last 1 decade, actually, we are saying we are focusing again on web application security. Right, that's why actually we have OWASP. But again, we are focusing on actually how to fix the problem, how to fix SQL injection, okay, how to fix other injection. But at the same time, we know that actually hackers are more smarter than us. And instead of actually looking only at how to fix the SQL injection, so if we need to go beyond actually, and we need to see if SQL injection, whatever I'm trying to do, if it is not solving the problem, Yame covered devaluation. If a hacker steals my data, is still valuable information that I lost. So if we devalue actually the data which he can hack, so that is the thing actually we need to see. For example, SQL injection. If SQL injection is not addressed, the entire database can be in the hands of hackers, right? So let me get into the details of the maturity model. Why do we need to talk about maturity model? Until we see the news about the data breaches, not from the small companies, like not from the startups, from the bigger companies, we need to keep on discussing on this maturity model. It's mean that there is still room actually for us actually to fix this problem. So everyone responsibility to educate this and improve this. So we tried actually putting this data protection solution maturity model, and every organization is focusing on enterprise security maturity model. How they can improve security maturity model overall, but they're giving like 1 line or 2 lines, hey, encrypt the data. So it's not giving actually the more details actually how exactly that encryption need to happen. So there is no specific timeline, there is no specific framework, there is no specific budget allocated actually for the data protection as such. So everyone need to get into the deeper of it and provide a charter and fix this problem. And I'm lucky, I'm in overall 20 years actually in this IT industry, and most of my time actually I spent in security. And I'm lucky to be part of Visa at this point of time. And before joining Visa, I was into completely product development. I was with RSA, Samsung, Huawei Technologies, many product companies I worked. I'm building security products. This is the first time actually I got an opportunity changing from preacher to actually implementer. Earlier I was preaching as a vendor to everyone, hey, you need to do this, you need to do this, you need to do this. But now actually I'm implementing that. And if some other company, maybe I will not get this opportunity. In Visa, I got an opportunity, as Subra mentioned, last 5 years, my primary focus is again, protecting the data and defining the data protection strategies and solutions in Visa. And this attempt is actually from that experience. So how exactly anyone actually can follow this? And this is actually a basic elements we put together and defined as a maturity model from level 1, level 2, level 3, level 4. And this is not the de facto. It is one of the basis actually, and someone can integrate more out of it. So as you were saying, actually, like we defined the level 1, which we're calling it the basic security. The major elements is every company has to know where is their data and what data is actually sensitive. So first they need to discover actually where is the data. When we say that data, we bother about what is sensitive information for that enterprise. So that is different for each organization. That's depending on the business model. So it will be changing. So they need to perform, actually everyone need to perform data discovery. Again, automated discoveries are not 100% covering. At the same time, you need to shell out a lot of process speed to discover actually where your data is. So it need to be a mix actually. So both automated discovery as well as manual discovery need to be done. And another one is a data, then we need to have a data protection functionality need to be available as a framework, availability. And the major features is like encryption and tokenization. Apart from that, once the data got protected, we need to provide access controls, both for data as well as key. Just for providing access control to data is not enough. So the key is the main key for the data to be protected. So the key access management, who can access the data, need to be addressed. So this we are calling it a level 1. So being said actually level 1, so definitely every product, whoever is developing enterprise product must need to ensure that they have this feature. At the same time, whoever implementing a product application in a company, either with a COTS application or homegrown application, they must need to address this. So why we said actually they must need to, in the last 4 years journey, I interacted with many big vendors, big product vendors, enterprise product vendors. Still, most of them are lacking this feature, encryption in their application. Their statement is, oh, we will not take care of it. The database administrator will take care of it. But we said, who is the owner of your data? Your application is the owner of your data, not the database administrator or not a system administrator. So you need to control how it need to be protected. Don't delegate actually your responsibility to the downstream. So we need to take it forward actually, and we need to see all vendors are addressing this problem. And the second one is the repeatable maturity. Again, data production. It's a very vague term. So where is the data? So data typically will be defined actually in 3 different places. And data at rest, in transit, and in use. So we need to ensure actually whether the data is getting protected at all these places, not at one place. Because the threat can happen actually anywhere. And another important factor actually, key to rotation and rekey capability. This is very important actually when we think of like what happens actually if the data is, key is leaked, key got compromised. So we always believe in the defense in depth. So whatever security controls we put, we know that actually it's not 100% secure. Okay, so we need to be prepared for the worst. So at the same time, the tiered approach, so application level, DB level, and the FS level. Like these are the different levels actually where the data will be managed at the application layer, and database layer, and the file system layer, and the last actually storage level. So where do we protect the data, and what is the results of it? And a solution framework, when an enterprise is designing, it need to have the solutions for all these levels. Okay. Yes, application level is the best. It's not mean that the solution should have only application level, because there are valid reasons why some applications cannot use application level data production. If you say my solution framework does not have DB level and system level, they will stop encrypting the data because they don't have application level data production. And level 3 is a managed security, managed maturity. So here we said actually, so far we are talking about level 1, level 2. It can be implemented by any organization, any product company, because it does not cost too much other than the development time. So whereas coming to the level 3, here we are talking about a centralized hardware-based key manager system. This can be invested actually in medium to the big companies. Whereas a small company, startup company, they may not be in a position to invest money actually on procuring HSMs and integrating with it. But with AWS and other services, yes, that is also possible. So that's why actually I moved this actually to level 3. Otherwise, that is also very important factor. So here, the keys need to be centrally managed. And another one is interoperable with KMIP and PKC11. These are the two standards. So who are familiar with the KMIP here? And PKC11? So the PKC11 is a 2-decade-old standard, which is very important actually to be known by every developer. Because if you don't know that, actually he don't know what is the capacity they can integrate with a centralized key manager. And in the same way, KMIP, which is a 1-decade-old standard from Oasis, and that is bringing actually 4th generation key management systems adoptable by any product and an application. So the last one is optimizing security. Whatever we do, the keys always need to be in the memory. Okay, so even it's a fraction of time, the keys, when they're in memory, there is a probability of attack. So that is a optimizing maturity. We need to see actually how exactly we can address it. So the latest one is SGX, but there are different features available actually to address this, but it's not 100% foolproof as of today. Okay, getting into a little bit details actually in the data discovery. So as I mentioned, actually automated and manual discovery need to be there. It's not just manual discovery or not just automated discovery. Automated discovery is very costly. As we have experience, we could not able to churn through all the trillions of records and to find out where is my sensitive data. So it should be collaborative, and the security teams need to discuss with each and every application architect and have a security architecture review and understand and ask them actually where is your data. And both the parties need to be responsible. It's not like just a security architect. And the development team need to know that actually why this question is posted to me. Okay, so they need to be open actually in terms of providing what sensitive data they have. And the data protection functionality, when I said encryption tokenization, so encryption was there for most of the time, as we know, but the tokenization again, it's like around 10 years old concept actually came. So the tokenization preserve, there are some use cases why some applications cannot adopt encryption. If they have a business logic actually which required the format of the same data, so they're discouraged actually to use the encryption. So that is the reason there are two major features came, like format preserving encryption and tokenization. So one solution need to have both of them. And as I mentioned, key access management, keys are crucial for overall data protection, and make sure you have a centralized key access control. It's not just like a local key access control. And the same with the data access controls. So the level 2, as I said, think beyond just at-rest protection. Okay, so we know that actually our responsibility is product data everywhere. But most of the places actually, when everyone focus on data at rest, so they say actually my data is resting at the storage. Yes, always the data will be resting at the storage only. It's not mean that actually we need to protect it rest only. Okay, so if we protect at rest 100%, like storage level, the threats on OS level and DB level and application level is not getting addressed. So it's almost like you're not providing a necessary security there. There are some cases where you cannot enable application level data protection. Only those cases you need to look for other alternatives and with other additional security controls. So the at rest actually you need to focus actually whatever the data is residing for more than specific time is considered data at rest. So that depending on actually each organization how the other security controls are. If your other security controls are very good, you can make it like if the data is residing more than 1 hour, then it is data at rest. But if you feel actually like the other security controls are not strong, then minimize that timeline also. So then call it as data at rest and take care of protecting the data. And in flight, so when the data moving from one component to another component, it's not only within the organization, with the partners outside the organization, make sure your data protection framework have a functionality to protect it actually on the while. It's not only the TLS. Just enabling the TLS is not enough. Because when you are interacting with the third-party entities, there are a lot of intermediate network hops actually will be there. If you are just relying on the TLS, the transport layer security, so you are protecting it up to the terminator, TLS terminator, not the end application. But if you see the owner of the data, the end applications are the owners of the data. It should not be with any other intermediate hops. And in use, as I mentioned, this is again a very, very tough problem to address. So in use, inside application, exactly when the data during processing, so the data actually will be in use. So we need to make sure actually like the data is protected in the threshold. Yes, it's a very, very challenging problem actually. So the level 2 actually still we are continuing here. It's as I mentioned actually the key rotation and rekeying is very important. So assume that actually I encrypted the data and the key cannot be rotated. So what happens actually in the overnight, in the middle of the night, someone says, hey, your keys got compromised. So there is no means actually to rotate it. Like you will ask actually the management, hey, give me 1 month time, I will shut down the service. Let me rotate the data. Let me rotate the key. So no. So you need to design actually your application integration thinking that you have a reason, you will have a need actually to rotate the key and have it by design so that actually like you can rotate the key and the rekey at any point of time. It's not only after 2 years. If someone asks you to rotate a key tonight, you should be in a position to rotate the key tonight without shutting down your application. So there are different actually proven methods available and just adopt them. So don't think that actually it is a aftermath. Don't think that, okay, let us see actually after 2 years because the key can be used actually for 2 years. So, but your application need to design such that actually it can use it. And if you are developing a product and you're integrating actually the encryption, make sure you provide this capability. And application level data production, as I mentioned, right? So the levels actually, we have application tier, database, and file system level and storage level. Okay, so all those things that actually you need to first, by default, think that actually how to solve the data production in my application layer. Because as an application owner, you are the owner for the data, not the database administrator or system administrator. So if you are not protecting it and delegating there, so you are leaving some room actually for attackers to attack your data. Okay, so always like and most of these languages, again, depending on actually your technologies, so you can increase the technologies there. So make sure actually your solution framework have the capability to integrate standard set of languages. And as I mentioned, PKCS11 and KMIP, so these are the standard protocols. So what we are seeing actually in most of the applications, some vendors, like enterprise vendors, so big vendors, the top 100 vendors, they are still not adopting this. The problem of not adopting this, no, I mean PKCS11 and KMIP. So if I'm a vendor XYZ, I say, yeah, I have actually capability for encryption. Right, where are you keeping your keys? Yes, I'm keeping the keys next to my data. So what is the use of it? I lock my house and I keep the key next to my door. So there is no value addition there. So some little bit more vendors, like around 40 to 50%, they're going forward and they're saying, yes, I'm encrypting the data and I'm keeping my key in another server. Hey, how do you interact actually with that server? Oh no, you need to buy this product. So why you need to buy this product? Because it is proprietary. So I already have external key managers in my organization. I spent a lot of money, and if each and every application vendor is saying, I have actually my own key management, use my key management system, and it's a proprietary, then it is a discouraging point to me. I will stop enabling actually external key management. So we are leaving a room for the opportunity to attack. Some vendors actually going forward and they're supporting PKCS11, which is a 2-decade world. Again, the problem with the PKCS11 is it's very interoperable, that's true. But in typically most of the industries, the HSMs are procured by need basis. And it's by application. So if you have 100 applications to be protected, you need to procure minimum of 200 HSMs. So it is not shareable. The infrastructure is not that easy to share between the applications, but the data is pretty much need to be shared from one application to another application. That is a need. It is not a option. That's a need. So the KMIP from Oasis, they brought up actually the key management interoperability protocol and calling it as a 4th generation key management systems. And they are making sure actually the application level key management shareability concept is addressed. So applications need to focus on actually adopting this KMIP. So as I mentioned, actually, if you are an enterprise, you are dealing with one of your vendor, talk to them, tell them you need actually KMIP. Okay. So at the same time, if you are a product vendor, and make sure actually you enable encryption also support KMIP. Yeah, and the database and file system, there are traditional transparent data encryptions available actually both at the file system level and database system level, and they can plug to the centralized key manager. So use that actually functionality, just not enable TDE, but also make sure actually integrate with the external key manager. That's where actually real problem is getting solved. If the key get compromised, there is no means of actually protecting the data. So the next level is actually FIPS level 140 to level 2 applications. As I mentioned, actually, like this is the next level of data production. So make sure actually you have the infrastructure which is cannot be compromised, where actually the keys are getting stored, and you design such that actually you have data encryption keys as well as key encryption keys. Okay, it's not again a hard and fast rule that you need to follow the exact pattern. Depending on your use case, how frequently you can go to the centralized key manager to fetch the key. Either you can keep key encryption keys or data encryption keys, but have the capability. So as I mentioned, KMIP and PKCS11 are important. Make sure actually like as a product offer vendors, please make sure actually like you are enabling these two. And level 4, as I mentioned, actually like in-memory key. So always the data, when you are protecting actually the key, you always need to bring it here for the performance reasons. So the best implementation is perform a encryption. If you can perform a remote encryption, that's best. But the performance always actually comes to the performance. And I spoke to actually one of my developer in 2000. So she was actually knowing about encryption from 2000 onwards. So she was developing one application. She said actually no, my manager did not ask me to enable encryption, but she's handling actually the sensitive data. So when people are actually implementing, actually they need to focus on encryptions and also. And in-memory protection is very, very important when you are actually enabling protection. So in-memory, but again, it's not 100% getting addressed as of today. So we have still a room actually to improve on these technologies. Yep. So these are the different building blocks. Actually, when we put together what are the different requirements we have for taking care of the data production, these are the items. So whatever we discussed so far, everything put together. Yes, the requirements comes in this way, not in a formalized manner. So now actually I will hand over to Oleg. He will be talking on like how exactly it need to be taken care for the data.
So returning to what this solution is built from, I would like to talk about like two aspects. Since we announced in our presentation that it will be related to DevSecOps, I would like to focus at the how we implement it in such a way that we are running at the same speed as everybody else, right? This is very important. You already seen that this is complex. Everything which is related to cryptography is complex. You've seen maturity model presented by Vinod, and you could see that there are a lot of things that you need to implement to get to the highest level of maturity. For big, heavily regulated companies, it's important to have it at level 4, right? And when you think about this and look at everything which is happening around, the natural question is how you implement it in such a way that everybody else is happy and you are not a showstopper. And there are two things that I would like to talk about here in this regard. the first thing, and I never seen this like actually in any DevOps or DevSecOps presentation, that people talk about architecture build right. I think the first thing that you need to have, you need to have like a really flexible API-based architecture, because if you don't have it, you cannot integrate it fast with anything. And this is like 6 layers that I come up with, which make sense to use when you want to build a comprehensive cryptographic system in your organization, which requires a high level of data protection. The most important thing from developers' point of view here is probably level 1. At level 1, you should have what I call external interfaces. These are interfaces that your developers team will be using. And you need to make sure that for each language that you have in your organization, you have such a library. These interfaces should be universal. You need to own these interfaces. You need to build them to make sure that when your backend provider is changing, or configuration is changing, or anything is changing backend, your users' applications are not affected. This is important because as soon as the developers implement something and move it to production, it's extremely difficult to get rid of it and to tell them to use something else. So that's why, again, I'm saying owning interfaces is very important, and this is what level 1 is all about. And the second part is probably not that obvious. When you try to talk to cryptographic backends, and we have different kind of hardware security appliances, we have software servers, gateway, and so on, you usually have a lot of configurations. These configurations are related to things like endpoints, to protocols that you are using. Most importantly, it's related to authentication and authorization. And if anyone works with any appliance, like for example, SafeNet or Ingredient, network attached encryption APIs, you will see that these configuration files are huge. There are a lot of parameters, so you need to abstract this as well. And that's why we have the second layer, which is mostly about configuration parameters and about things like authentication and authorization. So you can see that you can have LDAP to control access to HSM. You can have some kind of secure vault where you store in shared secrets. You can have some files stored in PKCS12 format or in Java key stores. You can have passwords. You can even have bearer tokens, which are coming from other authentication systems like OAuth. So it's important to have abstraction for this layer. And if you have just these two, everything becomes simpler from developers' point of view. They just create an object with all these parameters and then use something like Java factory pattern, for example, to derive a security provider that you can see at level 3 that will implement all interfaces that have been defined at level 1. Right? So this way, if something has changed on backend, the only thing the developers would need to do is to change their configuration file. Everything else will be the same. Then you would need to make sure that your specific crypto service providers are using protocols. You need to make sure that they understand these native APIs that I just mentioned, REST and SOAP APIs, which are very popular now in this domain as well. And finally, level 5 is kind of optional, but this is just like yet another abstraction layer. If you can create some universal interfaces on server layer so that you can simplify your development at layer 3 with your cryptographic service provider. So this way, all differences for calls coming from layer 3 to level 5 would be related to configuration, and everything else will be the same. You can do, again, any popular interface here. Protocol, do use any popular protocol like REST or something else. And the last layer, if you build all of that, the last layer, number 6, this is where all these specific HSMs, hardware security modules live. You can also have software servers like KMIP server. I'm like aware at least about one company which provides a good implementation called CryptSoft. So you consider those as well. There are other contemporary approach how you can replace these HSM modules with pure software solutions. It's related to multi-party computation in cryptography, and there are companies who are providing these solutions as well. So choices are many, as you see, but the most important part here, you need to own the interfaces, which you see at layer 1, and you need to make sure that your solution is vendor agnostic. All right, so now when we are done with architecture, let us take a look how you can run the whole program, your cryptographic solution, enterprise-wide cryptographic solution in agile manner. So usually this is like phases. This is phases that you see on the screen. They are not specific to the cryptography, but there are like tasks which are related in cryptography that you can solve to achieve a better speed of whatever you implement. So very often I've seen this misconception coming from DevSecOps advocates who were saying that, you know, if you're doing something manually, you're not doing DevOps or you're not doing DevSecOps. And this is probably true for small companies where everybody belongs either to DevSec or Ops category. For bigger companies, you see on the top at least like 3 items which you cannot completely automate, right? And again, we're required to do that because of different kind of regulations and processes that we have, our internal and external standards. You cannot automate architecture review completely. You cannot automate design review. You cannot automate planning. But you can use some workarounds and at least make it a semi-automated process, if not completely automated. For planning, where like you're thinking about licensing and probably provisioning some boxes, triggering architecture and design review, you might think about adopting some tools like, I don't know, ServiceNow, whatever, which will allow you to create a workflow. So you need to have a well-defined workflow, and in this workflow, it's important for each step to have SLA. It's also important to have some escalation procedures if those SLAs are not met. And this way, at least you cannot automate completely, but at least you will know approximately how much time would it take for you to complete the request to provision a new cryptographic service to your application. For architecture review, again, people are involved. It's important to have some standards because if a security architect has standards where everything is defined, it would be easier for him to do assessment and to tell developers what is missing. When you move to design, it's important to have different kind of patterns. It's important to have reference architecture, again, to make sure that all of that is reusable and is ready for anyone who wants to enable their cryptographic services. The last 3, like development, testing, and monitoring, this is where like you can apply the most of automation. For development, to make sure that developers don't need to go to read all the thousands of documents related to security compliance, you can just give them libraries, code snippets, and tell just use it and you will be compliant. That would be the best solution for developers. Testing, why testing is important? We probably many of you read this book created by DevOps founders like Gene Kim and others, the Phoenix Project. And remember, there was like an episode when SSN was encrypted, but it was not integrated well with other systems. As a result, nobody was able to receive their salary on time, right? So this is how critical problems with cryptography could be. It could be even worse. It could lead to data breaches and so on if you don't do it properly. So it's important to have regression frameworks for testing which are specific to cryptographic functions, because developers do have their own regression, but it's not necessarily related to algorithms and to parameters of those algorithms. They just will be testing functionality. So it's important from security part to provide this kind of framework to make sure that each time when configuration is changed, each time when vendor, for example, is changed on backend, so they could run it and see if there are any problems. Monitoring, again, can be automated and is very important. And we not talked already about importance of performance. So each time when we give our cryptographic service to anyone, we usually tell them how many encryption, decryption per second they will get. And the team, developers, then rely on this SLA to create their own SLAs. And if you like in online transaction business, it's very important to make sure that this SLA are met, otherwise the company will have legal and financial problems. So that's why it's very important that to create special kind of testing tools and framework that would evaluate first that system is alive, and the second one is that SLA is met related. For example, you can do a certain number of cryptographic operations per second. So this is like returning to planning. This is a very quick, okay, I'm running out of time, I'll be running faster. This is like a quick spreadsheet that can help everyone to choose the right level of data protection. Again, very important. Our preference here is application level encryption, and this is the most flexible where developers are owning everything. Then if it's not available, we would recommend database level encryption. If they're not dealing with structured data, if it's only file systems, then it's file level. And the last one is disk level. I should probably like reorder them, like, but this is the idea. So if you just read all that, I don't want like to explain and all pros and cons here. You can read it later on. But the idea is that you need to go from the best to the worst encryption, and this spreadsheet will help you to do that. So going to conclusions, like what will you achieve if like you apply this framework, if you do everything as we described. And enterprise level, you will have an agile and consistent data protection that would allow you to solve the most of your compliance problems to satisfy your internal and external security requirements. At product level, it's very important to have all these tools, libraries, and methodologies because it allows, it reduces the risk, first of all, of making a mistake when you do cryptography in product development teams. And it will speed up their processes, and it will save them time so they can do they can stay focused on their like real priorities, like creating new features and so on. And at DevOps, it's very important to have standardization, libraries, patterns, share them with developers to make sure again that they can run at DevOps speed. So we have, this is like, I will just bring all of them here. Key takeaways. The most interesting part here is that all these takeaways, if you like look at them and read them, you'll understand that they are basically all related to DevSecOps process, right? And it's very good that we can apply all of them to our use case when we are trying to implement a comprehensive cryptography and encryption program in a big organization. For example, data protection as a service. If you look at DevSecOps, you will see there an approach where everybody is saying security should be really implemented as a service. Vendor agnostic helps you to decouple your solution from any specific vendors. It requires you to be very careful with choosing vendors. Many presenters were saying that it's important to make sure that everything that you can do through UI can be done through API as well. So the same is here. Efficient processes and automation, again, I talked about this. Not everything can be automated, but there is always a way to use tools and to make sure that at least time expectations are set up right, and the users who need these cryptographic services to be implemented would know exactly how much time it will take to achieve that, and then they can plan properly. Standardization is very interesting part. Here is like one specific which is related to cryptography. It's very important in crypto. You remember this like statement that like just Karen Lu was talking about from Jamalta. You don't want to allow like everyone to implement their own cryptography, to build their own cryptographic algorithms. So standardization in cryptography, that's why it's very important, because you're basically reducing variability, you're reducing the API calls, you're removing some unsafe cryptographic algorithms and parameters, and they don't, from one hand, they don't need to think much about how to use it, and on the other hand, you are reducing the risk of making mistake when cryptography is being implemented. Champion security is very important as well. You all know that ratio between security engineers and developers is probably 1 to 10. If you limit the security engineers to those who look into cryptography, it probably will be 1 to 100, right? So it's important when you sit down with developers, telling them about your solution, it's very important to make sure that somebody can actually pick it up from dev team and then share this knowledge inside this dev team and probably in other dev teams as well.